Good afternoon, guys. Welcome to the 34th lecture of fluid mechanics. We are in the Unit 3 discussing about the nature of laminar flow and turbulent flow. So in the last few classes, we have discussed about the theories of laminar flow, turbulent flow, characteristics of laminar and turbulent flow, the velocity distribution in the laminar flow and turbulent flow. And also we have seen some problems in this unit. Today in this class, we'll discuss about the new topic, that is hydrodynamically smooth and rough boundaries of the pipes whenever the fluid is passing in the pipe. So whenever the fluid, that is water or oil, is flowing inside the pipe, so the wall boundaries may be smooth or rough. Then what happens to the forces acting on that? And what about the friction developed? What about the velocity distribution and average velocity? We see those things in this topic. So this topic covers the viscous nature and the turbulent nature of the fluid with respect to the smooth and rough boundaries, and also the derivations of smooth and rough boundaries added with some problems. So we will see these things in this class, right? Okay, we'll start the class. Yes. So now we are discussing about this hydrodynamically smooth and rough flows. So we will discuss this flow between parallel plates and flow between long tubes in the next session. So as we are having the current topic, hydrodynamically smooth and rough flows. So as derived in the textbooks, the derivation is very lengthy. I have cut short the derivations and I have written the statements which are very directly imposed and which are directly known to you, right? So if you're using the Reynolds expression for the turbulent shear stress, so generally as we know, tau is equals to stress is equals to rho into u into v dash, whereas u dash and v dash are fluctuating components of velocity in x and y direction. So if you take in the x direction, u dash is a fluctuating velocity. If you take y direction, v dash is a fluctuating velocity, right? U is equals to some sort of component in x direction, v is equals to some sort of component in y direction. Whereas u dash and v dash are fluctuating things in this x and y direction with respect to the velocity. Now tau bar is equals to tau u into rho u dash v dash bar. So this is nothing but a turbulent stress with the Reynolds expression. So you get some problems related to this expression, right? Next one is Prandtl mixing length theory. Next one is a Prandtl mixing length theory. So if you are taking the length of the pipe into consideration, then what about this one? So if you see, nu u dash is equals to length of the pipe into dou u by dy. Therefore, L is equals to mixing length between the two layers. Okay. Next, u dash is v dash is equals to length into dou u by dy. Right? Yeah. So today's topic is hydrodynamically. So whenever any student comes, you are getting the problem of this. Show you the slide. Okay, hydrodynamically smooth and rough boundaries. So here we are discussing the topic of Reynolds expression for turbulent shear stress. So generally tau is equals to rho into u into v with respect to the x direction and y direction of a velocity component. So if you are taking the mu is equals to rho into u dash into v dash bar. This is a turbulent shear stress by using the Reynolds expression. So if you get some problems by using this formula, we have to solve the problems. Next, Prandtl mixing length theory. So whenever the length of the pipe is also taking into consideration, there is the length of the pipe, then u dash is equals to L into du by dy. There v dash is equals to L into dv by dy. Now multiplying this u x into y direction, multiplying this x into y, u dash u bar into v dash bar is equals to length du by dy into length de v by dy. That is equals to L square du by dy whole square. Substituting this equation in this equation, tau bar is equals to rho into L square, substitute this one, right? So we are getting rho into L square, this one. So what is u dash bar into v dash bar? This is a u dash bar into v dash bar. Now substituting here, we are getting tau bar is equals to rho into L square du by dy square. Now the total shear is equals to viscous shear plus turbulent shear. So whenever we are discussing about the total shear stress in a pipe, we have to add both the turbulent shear plus laminar or viscous shear. So adding this to viscous shear plus turbulent shear, tau bar is equals to mu into du by dy plus turbulent shear is equals to rho L square du by dy square. And E substitutes E value what we have got from this 1 and 2. So this is a turbulent stress, shear stress. This is a viscous shear stress. So we are adding the total stress, tau bar is equals to viscous stress plus turbulent stress. These are used for turbulent fluid flow problems to determine the shear stress. So ఈ formula ఎక్కడ యూజ్ చేస్తాం? We are using for turbulent fluid flow problems to determine the shear stress. Got it? Now, next one is velocity distribution in turbulent flow. How the velocity is distributed in the turbulent flow whenever you are using uniform pipe. So tau bar is equals to rho into kv square, ky square into du by dy square. That implies du by dy is equals to 1 by ky root of tau naught by p. So that implies u is equals to u star by k log e y plus c. So actually you have a derivation for this, but there is no use of derivation for coming in the exam. So there is no importance of the derivation. So directly I have given the formula. So that is u is equals to velocity distribution u is equals to u max plus 2.5 u star log e into y by r. This is a Prandtl equation, right? This is a Prandtl equation. So I have written the formulas in this unit. What are the formulas you are getting for the part 1? So I have written the formulas step by step. Keep these formulas in your mind or practice these formulas. When you get any problem in the third unit 3, you have to apply any of these formulas and you have to start doing the problem, right? So in the initial classes, we have discussed about the first one is that is Darcy-Weisbach equation. HF, head loss, is equals to 4 into F into L into V square by 2 D into 2G, where F is equal to friction factor. The friction factor will change according to the velocity distribution. Next, the coefficient of friction for the shear stress is equals to tau naught is equals to F into rho V square by 2. This is the coefficient of friction for the shear stress. Next, the shear stress in the turbulent flow. The shear stress in the turbulent flow. So here, see here the shear stress in the turbulent flow. That implies tau is equals to viscous shear stress and in turbulent shear stress. So mu into du by dy plus rho into sigma into du bar by dy, du bar by dy. Students are coming very slowly. Okay. Next, where tau t is equal to turbulent shear stress, tau v is equals to stress of viscosity. This one is equals to eddy viscosity. U bar is equals to average viscosity. Therefore, the shear stress in the turbulent flow annappudu, we have to write both the viscous stress plus turbulent stress. Why? Because so directly we are not getting the turbulent flow in any container. So here the addition of viscous flow plus the transition flow give rise to turbulent flow. That's why the total stress is equals to tau v plus tau t. We have write in this manner, right? Okay, everyone has joined. So the three formulas for this one. Next, fourth formula is Reynolds expression for the stress. So the expression already మనం derive చేస్తాం, ఇందాక మనం derive చేసాం ఫస్ట్ దాంట్లో, this one, right? This is a Reynolds expression. Next, fifth one is Prandtl equation. So ఈ Prandtl equation కూడా ఇందాక మనము derive చేసాము. Tau bar is equals to mu into du by dy plus rho L square du by dy to the power of 6. Sixth one, velocity distribution in the turbulent flow. So how is the velocity distribution in the turbulent flow based upon the Prandtl velocity? So here the equation directly మనం రాస్తున్నాం. I didn't derive the equation. Why? Because exam లో రాదు కాబట్టి directly I am giving the formula. U is equals to U max plus 2.5 U star into log E y by R. This is a Prandtl velocity. Next formula, roughness Reynolds number. U star into K divided by V. That is a roughness Reynolds number. Next, velocity distribution in the smooth pipe. Smooth pipes లోపల velocity distribution ఎలా ఉంటుంది? U by U star is equals to 5.75 into log 10 into U star y by V plus 5.55. So these formulas you have to definitely by heart whenever you are getting the problems in the unit 3. So unit 3 lo problems vaste you have to learn these formulas and you have to start doing the problem, or else you will not get the solution. Okay na? That's why free time lo మీరు ప్రాక్టీస్ చేస్తూ ఉండండి. Next formula, velocity distribution in the rough pipe. So smooth pipe lo the value is like this. In the smooth pipe, this is the formula. In the rough pipes, formula కొంచెం పెరిగింది. U by U star is equals to 5.75 log 10 into y by k plus 8.5. So ఇక్కడ మనకి 5.55 ఉంది, ఇక్కడ log 10 y by k 8.5 ఉంది, right? సో ఓన్లీ మనకి చేంజ్ అయింది ఇక్కడ పాయింట్, ఇక్కడ పెరిగింది, ఇక్కడ చేంజ్ అయింది. ఓకేనా? నెక్స్ట్, velocity distribution in terms of average velocity. So what happens when you take average velocity? అంటే smooth ki rough ki మధ్యలో ఉండే average velocity. If you take for a smooth pipe, the average velocity is U bar by U star is equals to 5.75 log 10 U star into R by V plus 1.75. For rough pipe ki ఎలా ఉంటుంది? U bar by U star is equals to 5.75 log 10 R by K plus 4.75. Next, for C, difference of velocity at any point for smooth and rough pipes. So when you take the velocity distribution at any point with respect to smooth and rough pipes, U into V, U minus U bar by U star is equals to 5.75 log 10 Y by R plus 3.75. So E formulas definitely you have to by heart. Why? Because so if you get a question that in terms of smooth pipes ki ee formula తీసుకోవాలి, a rough pipe ki ee formula తీసుకోవాలి, between both rough and smooth ki ee formula తీసుకోవాలి. Got it? Yes. Next formula, coefficient of friction is given by, so ఇక్కడ మనం coefficient of friction పెట్టుకున్నాం కదా, see here this one, ఈ HF కి 4 into F into L into V square by D into 2G లో F ఫ్రిక్షన్ ఫ్యాక్టర్ ఉంది కదా, ఇక్కడ ఇక్కడ మనకి ఎఫ్ అనేది చేంజ్ అవుతుంది, డిపెండ్స్ అపాన్ ద టైప్స్ ఆఫ్ ఫ్లో. సో వెన్ యూ గెట్ ఏ క్వశ్చన్ డిపెండ్స్ అపాన్ ద డార్సీ వేస్బ్యాక్ ఈక్వేషన్, ఈ ఫార్ములా వేసి ఈ ఎఫ్ కి వాల్యూ మాత్రము దీని నుంచి తీసుకోవాలి. సో మీకు ప్రాబ్లమ్స్ వచ్చిన టైంలో I will discuss about the how to do the problem. So just you have to, one thing is that is a laminar flow na turbulent flow na. Just you have to separate by seeing the question, by reading the question you have to understand what type of flow. Why? Because in the unit 3 you are having both laminar flow and turbulent flow. But majority laga manaki turbulent flows untai kabatti just see the question, read the question once or twice in the examination and come to a conclusion that it is a laminar flow or turbulent flow. Next, F is equals to, for F is equals to 16 by Reynolds number. ఇది ఎప్పుడు లామినర్ ఫ్లోలో ఉన్నప్పుడు F is equals to 16 by RE. నెక్స్ట్ F is equals to 0.0791 divided by RE 1/4. That is for turbulent flow smooth pipe. Turbulent flow smooth pipe where RE less than 4000, greater than 4000, less than 10 to the power. Next, F value is equals to 0.0008 plus 0.5525 divided by RE into 0.257. This is for what? This is for RE less than 10 to the power of 5, but greater than 4 into 10 to the power of 7. Next, F value is equals to 1 by root 4 into F, that is equals to 2 log 10 RE Reynolds number by K plus 1.74. That is for what? That is for rough pipes. Okay. So manaki laminar flow vachindi, turbulent flow lo smooth pipe vachindi, turbulent flow lo rough pipe vachindi. So based upon the question, we have to use the formula and we have to use the value of F. Understood? So meeku problems chestunnappudu meeku nenu detail ga meeku difference chesi chupistanu. Just you concentrate on the formulas. అర్థమైంది కదా? So these are the formulas which you get in the unit 3. కానీ సగం వరకే, ఓన్లీ ఒక పార్ట్ ఫార్ములాస్. ఇంకా వేరే టాపిక్స్ ఉన్నాయి, దానికి మళ్ళీ సపరేట్ ఫార్ములాస్ నేను మీకు రాసి ఇస్తాను. ఐఎమ్ గెటింగ్ స్లీప్. సో మార్నింగ్ 3 క్లాసెస్ అయింది. సో యువర్ సీనియర్స్ హ్యావ్ ఎగ్జామ్, మీకు తెలుసు అనుకుంటా. ఇన్ఫర్మేషన్ ఐ థింక్ యూ గాట్. యువర్ super senior, second year kada, yeah, your super senior, that is 4th year students are now ready to write the 3-2 exams, third year second semester exams. October 12th nunchi they are having mid exams. Okay, 1 week mid exams ayin tarvata again they are having lab external exams. Dani tarvata they are having I think October 3rd week, after 20, 25, 26, they are having end examinations. So దీన్ని బట్టి చూస్తే fourth years ఎగ్జామ్స్ అయిపోయినాయి. థర్డ్ ఇయర్స్ ఫోర్త్ ఇయర్కి వచ్చిన వాళ్ళకి ఇప్పుడు ఎగ్జామ్స్ వాళ్ళకి షెడ్యూల్ రిలీజ్ అయింది. ఇంకొన్ని రోజుల తర్వాత సెకండ్ ఇయర్కి ఎగ్జామ్ టైం టేబుల్ రిలీజ్ అవుతుంది. అంటే సెకండ్ ఇయర్ నుంచి థర్డ్ ఇయర్ వచ్చిన వాళ్ళకి తర్వాత నెక్స్ట్ టార్గెట్ మీరు ఉంటారు. అంటే ఫస్ట్ ఇయర్ నుంచి సెకండ్ ఇయర్కి వచ్చిన వాళ్ళకి మీకు 1-2 సెమిస్టర్ ఎగ్జామ్స్ కూడా ఛాన్సెస్ ఉండడానికి ఎక్కువ అవకాశాలు ఉన్నాయి. సో కీప్ దోస్ థింగ్స్ ఇన్ మైండ్ అండ్ బీ ప్రిపేర్డ్ ఫర్ యువర్ బిఫోర్ సెమిస్టర్ సబ్జెక్ట్స్ ఆల్సో. సో కరెంట్ సెమిస్టర్ అంటే 2-1 సెమిస్టర్ సబ్జెక్ట్స్ని కూడా మైండ్లో పెట్టుకొని ఫస్ట్ ఇయర్ సెకండ్ సెమిస్టర్ సబ్జెక్ట్స్ని కూడా మీరు ఇంకొకసారి బయటికి తీసి దాని సిలబస్ చూసుకొని అప్పుడప్పుడు దాన్ని కొంచెం చదువుకుంటూ ఉండండి అలాంగ్ విత్ దిస్ కరెంట్ సెమిస్టర్. సో దిస్ ఇస్ ద టైమ్ ఫర్ యూ టు థింక్ సీరియస్లీ హౌ వెల్ యు ఆర్ డిజైనింగ్ యువర్ టైం టేబుల్ ఇన్ ఎ డైలీ వైజ్. సో మీరు కాలేజ్కి వెళ్ళాల్సిన అవసరం లేదు కాబట్టి సో అట్ యువర్ హోమ్ మేక్ ఎ టైం టేబుల్. మండే రోజు ఏమేమి చదవాలి, అట్లీస్ట్ 1 అవర్, అట్లీస్ట్ ఒక 2 అవర్స్, ఒక 1 అవర్ ఒక సబ్జెక్ట్కి, 1 అవర్ ఇంకొక సబ్జెక్ట్కి, 1 అవర్ కరెంట్ సబ్జెక్ట్, అదర్ అవర్ ప్రీవియస్ సబ్జెక్ట్, ప్రీవియస్ సెమిస్టర్. సో అప్పుడప్పుడు మీరు ప్రాక్టీస్ చేసుకుని అలవాటు చేసుకోండి. సో మీరు కాలేజీలో ఉన్నారంటే అకార్డింగ్ టు యువర్ కాలేజ్ క్లాస్ టైం టేబుల్ యూ హ్యావ్ టు ఫాలో ద సబ్జెక్ట్స్. కానీ ఇప్పుడు మీరు ఇంట్లో ఉన్నారు కాబట్టి యు ఆర్ ద బాస్ ఆఫ్ యువర్ టైం. సో మీకంతకు మీరే పర్సనల్గా ఒక టైం టేబుల్ వేసుకొని దాని ప్రకారంగా టైంకి లేవడం, టైంకి ఫుడ్ చేయడం, టైంకి టైం పాస్ చేయడం, మళ్ళీ టైంకి చదువుకోవడం. సో ప్రాక్టీస్ ఇప్పుడు ఇట్లా చేస్తేనే రేపు ఎగ్జామ్స్ మీకు ఒక 10 days ముందు తెలిసినప్పుడు మీకు అలవాటు పడతారు. ఓన్లీ ది థింగ్ ఈస్ ఇన్ ది వరల్డ్ ప్రాక్టీస్. కొంతమంది ప్రాక్టీస్ చెయ్యాలని ప్రాక్టీస్ చేస్తారు, కొంతమంది అది ప్రాక్టీస్ అని తెలుసుకోకుండానే అలవాటు చేసేసుకుంటారు. సో ప్రాక్టీస్ అనేది తెలుసుకోకుండా అలవాటు చేసుకోవడంలో దట్ ఈస్ నార్మల్ థింగ్. ఎగ్జాంపుల్ ఏంటి, మీరు మార్నింగ్ లేవగానే ఏం చేస్తారు? బ్రష్ ద టీత్, హ్యావ్ ఏ కాఫీ, హ్యావ్ ఎ టీ, హ్యావ్ ఏ బాత్. ఇది మీకు తెలియదు, కానీ రొటీన్ లైఫ్లో వెళ్ళిపోతుంది. కానీ అదే పనిగా ప్రాక్టీస్ చేయాల్సినప్పుడు మీకు ఒళ్ళు బద్ధకం వస్తుంది. సో దట్స్ వై మీకు మీ సీనియర్స్కి టైం టేబుల్ వచ్చింది, తర్వాత మీ సూపర్ సీనియర్స్కి టైం టేబుల్ వచ్చింది, మీ సీనియర్స్కి వస్తుంది కొన్ని రోజుల తర్వాత మీకు కూడా వస్తుంది. సో దట్స్ వై బీ అవేర్ ఆఫ్ ద థింగ్స్ అండ్ స్టార్ట్ ప్రాక్టీసింగ్ ఆర్ స్టార్ట్ డూయింగ్ సంథింగ్ ఫ్రమ్ దిస్ వీక్ ఆన్వర్డ్స్. ఏదో ఒక రోజు అనుకొని స్టార్ట్ చేయండి. ఎస్, ఓకే, come to the class. The next topic in this is hydrodynamically. Hydrodynamically smooth and rough boundaries. Okay, so ఈ formulas already next ముందుగానే చెప్పేసాను formulas. Okay, now see the figures A and B. This is a smooth and this is a rough boundary. This is a smooth boundary, this is a rough boundary. So ఇది laminar sublayer అనుకుంటే, this is a laminar sublayer with a rough boundaries. See the boundary here. The boundary here is, which is not uniform, but you are having a clear vision of this K, right? So whereas coming to here, you are having a close, tight structure of the layer boundary. Okay, so this is a laminar sublayer, this is a laminar sublayer. So let K is the average height of the irregularities projecting from the surface of the boundary. So what is it saying from the figure? So K is the thickness, K is the height of the irregular projecting from the surface of the boundary. If the value of K is large for a boundary, then it is called rough boundary line. Okay, na? Whenever the value K is larger, we are calling them as rough boundary. So ఈ K distance అనేది ఎక్కువ ఉందనుకోండి, we are calling them as a rough boundary. And if the value of K is less, then the boundary is known as smooth boundary. This is a classification of rough and smooth boundaries based upon the boundary characteristics. So గుర్తుపెట్టుకోండి, whenever K value is large, we are saying them as a rough boundary. Whenever the value of K is small, we are calling them as a smooth boundary. But for proper classification, the flow of fluid characteristics are also be considered. So ఇంకొంచెం డీటెయిల్ గా మనకి కావాలి కాబట్టి the flow and the fluid characteristics also should be considered. Okay, now this for turbulent flow analysis along the boundary, the flow is divided into two portions. So turbulent flow మనం తీసుకుంటే, the flow along the boundaries లో the flow is divided into two categories, two portions. The first portion consists of a thin layer of the fluid in the immediate neighboring of the boundary. So if you take the immediate neighboring hood of the boundary, where the viscous shear stress predominates while the shear stress due to the turbulent is negligible. So here in the turbulent flow analysis, the flow is divided into two portions. One is thin layer, another one is a thick layer. This portion is known as laminar sublayer. The height up to which the effect of viscosity predominates in this zone is denoted by the second portion of the flow where shear stress is due to the turbulent. Second flow and the first portion is a thin layer of fluid. The second portion is where shear stress due to the turbulence is large as compared to the viscous flow, is known as turbulent zone, which is known as a turbulent zone. So vocal layer, initial layer will be the thin layer, next layer will be the turbulent zone layer, which is large. So just showing the differentiation, how the smooth boundary work ela chestundi, rough boundary lo ela untundani చూపించడానికి they are showing the things here. So see the height, see the distance of the laminar sublayer in the smooth boundary, see the distance of the rough boundary in the for the laminar sublayer, right? So if the average height k, if the average height k projecting from the surface of the boundary, which is less than this gamma, which is less than this, the thickness of the sublayer will be shown in 10.4a. The boundary is called smooth boundary. This is because the outer laminar, so this will not come in the exam, just only for your understanding. This type of boundary is called hydrodynamically smooth boundary. Which one? The outside of the laminar sublayer is flow, is turbulent, and the eddies of the present in the turbulent flow try to penetrate the laminar sublayer, but due to the great thickness of the laminar sublayer, the eddies are unable to reach the surface irregularities, and this type of thing is known as hydrodynamically smooth boundary, right? Now, if the Reynolds number Re of the flow is increased, the thickness of the laminar sublayer will decrease, right? Then what happens? The thickness of laminar sublayer becomes much smaller than the average height of K. See in the figure B. So it becomes smaller. It becomes smaller. So when the distance is larger, here the K is smaller. When the distance is smaller, the K is larger. Understood? So that type of boundary, we are calling them as a hydrodynamically rough boundary. We are calling them as hydrodynamically rough boundary. Here, the irregularities of the surface are above the laminar sublayer, and the eddies present in the turbulent zone can come in contact with the irregularities. So the eddies are not coming in contact with the irregularities, but here the eddies are coming in contact with the irregularities of the surface, and a lot of energy will be lost. Then that type of thing we are calling them as a hydrodynamically rough boundary layer. Got it? Next, from the above experiment, from the Nikodeus experiment, if k by tau, if k by sigma dash is less than 0.25, the boundary is called smooth boundary. If k by sigma dash is greater than 6, the boundary is rough. So ఈ values కొంచెం మీరు గుర్తుపెట్టుకోవాలి. Otherwise, if the question gets in brackets, assume, then it will be very easy. Okay. So if 0.25 is less than k by delta dash less than 6, ఈ range లో ఉంటే, then the boundary layer is transition. In terms of roughness Reynolds number, U star into k divided by v. Therefore, if u by k, if the roughness number is less than 4, the boundary is smooth. అంటే ఇవన్నీ ఎప్పుడు చెప్పుకోవడానికి, క్వశ్చన్స్ లో if you get any conclusion, then you have to say greater than 6 ఉందనుకోండి, you are calling them as a rough boundary. If the value you got an answer is less than, it is transition. If it is less than 4, you have to say it is a smooth flow. If it is in between 4 and 100, we have to say it is a transition flow. If it is greater than 100, we have to say that it's a rough flow, right? So ivanni only the conclusions or statements at the end of the question where you have to focus. So generally in the question kuda meeku they will say that is the boundary is rough. So definitely if it is less than greater than 100, we can say the boundary is rough. So our conclusion statements చూడడానికి మనకి if అనే కొన్ని స్టేట్మెంట్స్ మనం ఇక్కడ చూపిస్తున్నాం. So here if you get a question, just a 2 marks question, state hydrodynamically smooth and rough boundaries అని ఇస్తారు. అప్పుడు మీరు దీన్ని ఈ ఫిగర్ వేసుకొని దీన్ని don't explain all the things. ఇంత సోది ఇంత ఎక్స్ప్లెయిన్ చేయాల్సిన అవసరం లేదు. just draw the figure roughly and show the distances here. So ఇక్కడ మనకి స్మూత్ బౌండరీస్ ఎప్పుడు చెప్తున్నాము, great thickness of laminar sublayer, eddies are not able to reach the surface irregularities, and the sublayer system is low. So here the thickness sublayer becomes smaller than the average height, and also the irregularities on the surface may be above laminar sublayer. Eddies present in a turbulent zone, and the turbulent zone will become in contact with the irregularities. అప్పుడు మనము హైడ్రోడైనమికల్లీ రఫ్ బౌండరీ అని మనం చెప్తున్నాం. నెక్స్ట్ వన్. సో ఈ ఫార్ములాస్ ఆల్రెడీ నేను మీకు ముందు స్లైడ్స్ చూపించాను. Now we'll see how to derive this formula. Velocity distribution of turbulent flow in the smooth pipes. So if you get a question like this, derive the velocity distribution of turbulent flow in the smooth pipes annappudu you have to draw this, right? You have to write these things. The velocity distribution of turbulent flow in smooth pipes or rough pipes is given by, so under E equation nunchi we have to derive a smooth flow and rough flow. So U is equals to U star by K into log Y plus C. Then at Y is equals to 0, the velocity U at wall is minus infinity. This means the velocity U is positive, right? And if it is minus, the velocity is negative. Hence, the sum of the fire distance from the wall will be 0. So let us take the distance from the pipe wall. అంటే ఇది pipe అనుకుంటే ఈ pipe లోపల నుంచి వాటర్ వెళ్తుంది కదా, some type of fluid is going. So this is a pipe wall. Inside ఉన్నది the pipe wall. Okay, the pipe wall from the distance from the pipe wall is y dash. Now the constant C is determined from the boundary condition, that is at y is equals to y dash, U is equal to 0. Therefore the equation becomes U place lo 0 pettandi, okay, y place lo y dash pettandi. Therefore 0 is equals to U dash by K into log E y dash plus C. Okay, or వేరే విధంగా ఎలా రాయొచ్చు, కాన్స్టెంట్ C ని పక్కన పెట్టేసుకొని C is equals to దీన్ని ఇటు సైడ్ తీసుకొస్తే మైనస్ లోకి వస్తుంది, మైనస్ U star by K into log E into y dash. Now substituting the value of C in above equations, what we'll get, U is equals to U star by K log E y minus U star by K log E y dash is equals to common ga U star by K తీసుకొని log E into y by y dash పెట్టండి. Now substituting the value of K is equals to 0.4, K is equals to 0.4, what we are getting, U is equals to U star by 0.4 into log E y by y dash, that is equals to 2.5 U star log E y dash y into y dash. Therefore U by U star is equals to 2.5 into 2.3 log 10 y by y dash. How you are getting this one? Since log E into y by y dash is equals to 2.3 log 10 y by y dash. So substituting this one here, you got this value. Now after substituting, U by U dash U star is equals to 5.75 into log y by y star y by y dash. This 10.19 is for smooth boundary where the laminar subsystem is shown in the figure. The velocity distribution of laminar subsystem is parabolic in nature. Thus, the sublaminar logarithmic velocity distribution does not hold good. So this is assumed by y bar is proportional to delta bar, and where delta bar is the thickness of the laminar sublayer. Now Nicodemus experiment is a value of y is given by, so how to write this value of y? Y bar is equal to sigma bar dash by 107, where sigma dash is equals to 11.6 into V by U star, where V is equals to kinematic viscosity of the fluid, where K y dash is equals to 11.6 V into 1.7. That implies y bar is equals to 0.108 V into U star. So substituting the value of y in the equation 10.19, the E values lo దీనిలో substitute చేస్తే ఈ 10.19 లో సబ్స్టిట్యూట్ చేస్తే విచ్ వన్ ద వాల్యూ ఆఫ్ y dash, the value of y dash substitute చేస్తే what we will get here, u by u star is equals to 5.75 into log 10 divided by y by ఈ వాల్యూ ఇక్కడ రాయండి y star value, right? Therefore u by u star is equals to 5.75 into log 10 y into u star divided by 0.108v. That implies 5.75 into log 10 u star by v divided by b into 9.259. Why this one? So 1 by 0.0108 మనము 9.259 గా రాస్తున్నాం. Therefore 5.75 into log 10 uv by v plus 5.75 log e plus 9.259. Therefore 5.75 log 10 is log 10 u star into v by v is equals to 5.55, right? So this equation 10.20, this equation, this equation is for the smooth pipes. So this is for smooth pipe. So ఈ ఫార్ములా ఆల్రెడీ నేను మీకు ఇక్కడ రాశాను రిటర్న్ పేపర్ మీద. ఓకే, నెక్స్ట్ velocity distribution of turbulent flow in the rough pipe. So in case of rough boundaries, ఏమనుకున్నాం, the thickness of the laminar sublayer is very small. Thickness is very small. Other laminar flow thickness is very large. Okay, now the surface irregularities are above the laminar sublayer and hence the laminar sublayer is completely destroyed. Therefore y bar can be considered proportional to the height of the protrusions k. Euclid's experiment shows the value of y bar, y dash for pipes coated with uniform sand as y dash is equals to k by 30. Now substituting value of k in the equation 10.19, so the same మళ్ళీ దీంట్లోనే ఇలా సబ్స్టిట్యూట్ చేస్తే u by u star is equal to 5.75 into 10 to the log 10 into y by k by 30, that is equals to 5.75 log 10 y by k 30. That implies 5.75 log 10 y by k plus 5.75 log 10 30, that is equals to 5.75 into log 10 y by k plus 8.5. This is the for rough pipes. Got it? So ఇక్కడ చూడండి, స్మూత్ పైప్స్ కి 5.75 into log 10, సేమ్ 5.75 into log 10. ఇక్కడ u star v by v అని ఉంది, ఇక్కడ జస్ట్ ఓన్లీ k by y by k ఉంది, ప్లస్ 5.5 ఉంది. ఇక్కడ you are getting 8.5. So in the smooth flow you are getting 5.5, in the rough flow you are getting 8.5. So like this you can have some small changes while keeping these formulas in the mind. Okay na? So with this formulas keeping in mind, we'll solve some problems related to this topic. Understood till here? Anyone? Any doubts? Just message me. Anyone? Raviteja, Sheikh, Sandeep, Snehalata. Anyone just text me or talk to me. How you are feeling this session? Anyone? అర్థమవుతున్నాయా లేదా? Getting or not? Students, just message me getting or not. Yes, sir. Right. Okay. Yes, sir. Okay. Right. So based upon these formulas, మీకు ప్రతి యూనిట్కి నేను క్వశ్చన్స్ చెప్తాను, క్వశ్చన్ పేపర్స్ ఇలా ఉంటుందని. సో మెజారిటీలీ వాట్ ఆర్ ద డెరివేషన్స్ యూ ఆర్ గెటింగ్ ఇన్ ఈచ్ యూనిట్ అండ్ వాట్ స్టైల్ ఆఫ్ ప్రాబ్లమ్స్ యూ ఆర్ గెటింగ్ విల్ డిస్కస్ అట్ ద ఎండ్ ఆఫ్ ద సిలబస్. డోంట్ గెట్ వరీ, జస్ట్ మీరు ప్రాక్టీస్ చేయండి, అటెన్షన్ పే చేయండి చాలు. ఏ యూనిట్లో ఏమేమి ఉన్నాయో తెలుసుకుంటే సరిపోతుంది ఫస్ట్ థింగ్. నౌ సో So based upon those formulas, we'll start doing the problems. So the time is also very less. మనం ఈ maximum 1-2 problems చెప్పుకొని we're having number of problems. Okay, don't get nervous. We'll go slowly and steadily. Okay, right. Now see the first question. Oh God. A pipeline carrying water has average height of irregularities projecting from the surface of the boundary of the pipe is 0.15. So what is the height K? ఇప్పుడు K irregularities గురించి మాట్లాడుతున్నాం. irregularities ఎంత ఇచ్చాడు? irregularities మనం దేంతో మెన్షన్ చేస్తున్నాము? K తో మెన్షన్ చేస్తున్నాం. K is a irregularity. ఓకేనా? K is a irregularity. See here, the average height K of irregularities projecting from the surface of the boundary, and so K should be regular. Projecting from the surface is 0.15. What type of boundary is it? Then the shear stress developed is 4.9 Newton per meter square. The KE of water is 0.1 Stokes. Then first frame the given data. What is the given data? The average height of the irregularities is 0.15. That is K is equals to 0.15 mm. Conversion meters per just 0.15 into 10 to the power of -3 meters. Now, what are the stresses developed tau? The stresses developed tau naught is equals to 4.9 Newton per meter square. Right? Then the kinetic viscosity. The kinetic viscosity V is equals to 0.1 Stokes. Convert into meters, 0.01 into 10 to the power of 4 meters square per second. Now the density of water rho is equal to 1000, as all know. Now, so based upon these values, what is the formula you have to take? The shear velocity U star is equals to root of tau naught divided by rho. Therefore, root of 4.9 divided by 1000 is equals to 0.07 meters per second. Got it? So just derivation ante. Just applying this one, U star shear velocity kanukkoli kabatti U star is equals to root of tau naught by rho. Now what is the Reynolds number? Reynolds number is U star K by V. Therefore, substituting U star value and K value divided by V, we are getting 10.5. Now the U star K by V, so value ఎంత వచ్చింది మనకి 10.5 వచ్చింది కాబట్టి it is lying between 4 and 100. And what is the boundary? What is the type of flow it is having? So ఈ రెండింటి మధ్యలో ఉంది కాబట్టి we are calling them as transition boundary. Got it? So the value what you got, what is the conclusion you have to give? 10.5 is the transition boundary for the pipe అని మీరు కంక్లూడ్ చేయాలి. Right? Next problem. A round pipe of diameter 88 centimeter. A round pipe of diameter 8 centimeter. The velocity at the point 3 centimeters from a wall is 30% more than the velocity at a point 1 centimeter from the pipe. Determine the average height of the roughness. So what is the given data? The given data is the, so ఇక్కడ ఆల్రెడీ మనకి మెన్షన్ చేశాడు, it is a rough pipe అని. ముందు దానిలో it is not mentioned, but it is asked what is the type of boundary. Okay. So I think the time is completed, less than 1 minute. So I will stop here. We'll discuss the class tomorrow. Okay. So I will share this video in the channel. Later the link is forwarded to you. Just open it, see it, and share this link to other students, those who are not in the class. At least మీకు క్లాస్లో ఎంతమంది ఉన్నారో దానికి మినిమం if you view the things so that the management will see automatically. So మీకు ఎంతమంది చూస్తారో automatically they knows that. So that's why be stable, be uniform, okay, and listen things. Right? Thanks for watching this video. Hope we'll continue the class in the tomorrow session. Have a nice day.